Hey guys, it's Jack again with another video. Sorry for not being able to post last week. I was very busy with the campers. I put up two very in-depth example problems, basically going through and writing out what I would have said in the video. Let me know if those were helpful. I can try and incorporate more of that in the stuff I post, but I'm back to videos for now. This week's video, this first one's the easier problem. It is a simple stoichiometry problem. It is from the Tro textbook. It is problem 109 from chapter 3. And so I like this one because you have to work on stoichiometry. It's a really easy stoichiometry problem, but you also have to have your ions memorized that we talked about earlier in the year that were on the memorization list. So it is sodium carbonate. So the problem is that a reaction of sodium carbonate with copper 2 chloride forms solid copper 2 carbonate and aqueous sodium chloride. So I'm just going to scribble that down to the side real quick so I can see it. Okay, so I will switch to my work screen. It's pulling up. There we go. Okay, and so yeah, the problem reads, you have your aqueous sodium carbonate reacts with aqueous copper 2 chloride to form solid copper 2 carbonate and aqueous sodium chloride. So the reason I chose this problem is because it, as I said earlier, it requires the use of stoichiometry, but it also makes sure you have your ions and stuff memorized. And so the first one is sodium carbonate. So sodium is a first row metal. It has a charge of 1. And so sodium carbonate, so we know that it's Na plus, and carbonate is CO3 2 minus. And so if we drag and drop the numbers, as my teacher in high school would say it, that makes it Na2CO3. And you have to remember to put the aqueous sign right there. Okay, and that is added to aqueous copper 2 chloride. It's the same thing, it's Cu. The 2 right here is telling you that it's 2 plus. And then it is chloride, which is a single charge. So again, if you'll drag them and drop them to the bottom, that gives you CuCl2 aqueous. This yields copper 2 plus and carbonate 2 minus. And so if you drag both these down, they're both 2, right? These both become, they're both 2s, and those can reduce down to a 1. So it's just CuCO3, solid. And then it also forms aqueous sodium chloride, both of which have a charge of 1, have opposing charges of 1, forming just NaCl, aqueous. Okay, so the first thing I do when I'm balancing is I'll write down what elements we have, right? So we have sodium, carbon, oxygen, copper, and chloride. To start with, on the left, we have 2 sodium, 1 carbon, 3 oxygen, 1 copper, and 2 chloride. If we go to the right side, we have 1 sodium, we have, let's see what else we have. We have 1 sodium, and then for carbon, we have just one carbon. We have 3 oxygens already. We have 1 copper, and we have 1 Cl. So looking at this, we can see that these middle 3 are already balanced, right? Both sides have the same amount of those elements. And then we look over and we see that the sodium and the chlorine have different, are unbalanced. They do not have the same amount on each side. And so we need to increase both the sodium and the chloride on the right side to balance it. And so if we look over, we see that the NaCl over here, if we put a 2 in front of that, that would cause this to go to a 2 and cause this to go to a 2. So this one was a pretty simple problem. It only required one thing to be balanced, but you can work these problems out where you'll have to go multiple times out from this middle thing to balance them. And you don't have to use this middle thing. I use it sometimes on the more complicated ones, but at other times you can just go through, just make sure you keep track of every single element. Also, something important to remember is that there is an invisible or an assumed 1 in front of all of these. So that is it fully balanced, but we do not need to see the 1s because they are assumed. Yep. So that is it for this quick example problem. It was good practice for, going from your ions, bringing back those polyatomic ions from the beginning. You have to remember to include these little signs down here: aqueous, solid, gas, liquid. Those are important. You need to know the state of your ions. It definitely becomes more important later on in the unit. Some important practice with writing out ions from, or writing out combined molecules from ions, so making ionic compounds, and yeah, and then some simple stoic practice. I hope this video helped, and I will see you in the next one.